Motorola uses several types of specialized robots to assemble electronic products accurately and quickly. The parts are picked from a feeder carriage by one of the vacuum nozzles on the rotating turret. The actual throughput depends on the number and variety of parts in the machine, like time to load and unload a panel in the machine, time to visually inspect visual marks, and to calibrate the position of the panel with respect to the coordinate system of the machine.
So the first step when trying to find the number of cellular phones that Motorola can make, we must first follow the equation where N is the number of boards per panel, P is the number of parts per board, C is the takt time, L is the load-unload time, and M is the mark reading time.
Here we have the equation given to us using all of the variables previously mentioned.
So with that, throughout T with the number of parts per board, P if there are 3 boards per panel, the load-unload time is 5 seconds, the mark reading is 1 second, and the takt time is 0.2 seconds. We substitute the N for 3, the C for 0.2, the N for 3, P, which is the number of boards per panel. We substitute L for 5, and we substitute M for 1. Okay, so now that we have done that, we must now simplify the equation. So now we get T equals 3 divided by 0.6 P plus 6. And with that equation, we can now determine the number of parts per board P.
Next, we have to determine the number of parts per board, P, if throughput T is to be 360 boards per hour, which is equivalent to 0.1 boards per second. We use the equation from the first problem, which is T equals 3 over 0.6 P plus 6. And then I plugged in 0.1 for T and set it equal to 3 over 0.6 P plus 6. Then I got rid of the denominator by multiplying it by both sides, and I got 0.06 P plus 0.6 equals 3. Then I subtracted 0.6 from both sides and got 0.06 P equals 2.4. Then I simplified it to get P, and P equals 40, which is the number of parts per board.
So now we're going to determine the number of parts per board, P, if throughput T is 540 boards per hour and 0.15 board per second. In order to find the answer for our problem, we need to look at the equation that was given to us originally, which is T equals 3 over 0.6 P plus 6. We use the given value that was given to us in the equation, 0.15 board per second, and we substitute that for T. Now we just have to solve for P. The first thing that we do is cancel out the 0.6 P plus 6 so that we can get it on the left side. We do that by multiplying each side by 0.6 P plus 6. That gives you 0.6 P plus 6 times 15 equals 3. Now we need to get rid of the 0.15. We do that by dividing 0.15 on each side. That will give you 0.6 P plus 6 equals 20. From there, we continue to get smaller and smaller and closer to P. We do this by subtracting 6 on each side, so 0.6 P plus 6 minus 6 equals 20 minus 6, which is 0.6 P equals 14. Now, we're so close to P, all we have to do now is divide it by 0.6. So 0.6 P divided by 0.6 is P, and 14 over 0.6 gives you 23.3.
Now we're going to determine the takt time C if the throughput is 216 boards per hour, 0.06 boards per second, with 3 boards per panel, 100 parts per board, and the mark receding is 1 second with the load-unload time at 5 seconds. In order to find that, we're going to use the equation from the first question. So we have T equals N over C NP plus L plus M. 0.06 is our throughput, so we're going to put it here as T. And then our N is 3, which is the boards per panel. And then we're looking for C. The N was 3, which was the boards per panel. 100, which was P, and it's the parts per board, plus 5, which was L, which is our load time, and then 1, which is M, which is the mark reading, which was 1 second. So after we plug all these into the equation, we're going to multiply. So first we have 3 times 100 and 5 plus 1. So we get 300C plus 6. We're going to take out the 3 from the denominator. So we pull it out and we get 3 times 100C plus 2. And then we can cancel out the 3 that's in the numerator and the denominator. And then we're left with 1 over 100C plus 2. And then from there, we're going to move the equation around to get 1 equals 0.06 times 100C plus 2. From there, we're going to multiply the 0.06 times 100C plus 2, and we get 1 equals 6C plus 0.12. From there, we're going to move the 6C to the left and the 1 to the right. So then we end up with 6C equals 1 minus 0.12. Then 1 minus 0.12, we get 6C equals 0.88. And then finally, we're going to divide both sides by 6. C equals 0.146 seconds. So when the parts per board equals 100, we're left with takt time of 0.146 seconds.
Determine the takt time C if the throughput is 216 boards per hour or 0.06 boards per second. There are 3 boards per panel, 150 parts per board. The mark reading is 1 second and the load/unload time is 5 seconds. We'll be using the same formula as Veronica used in number 4, which is T equals N over CNP plus L plus M. And you will be inputting your numbers from your question into the equation. So you would have 0.06 equals 3 over C times 3 times 150 plus 5 plus 1. Now multiply and add everything in the denominator, which will give you 0.06 equals 3 over 450C plus 6. Factor the denominator, and then you get 0.06 equals 3 over 3 in parentheses 150C plus 2 close parentheses. Now that you have a 3 on the top and in the denominator, you can cross them out, which would leave you with 0.06 equals 1 over 150C plus 2. Then I moved 0.06 times 150C plus 2 equals 1. After you factor 0.06 into 150C plus 2, you get 9C plus 0.12 equal 1. Then you moved 0.12 to the other side and you get 0.88. It leaves you with 9C equals 0.88. And you divide both sides by 9, which will leave you with C equals 0.097.
To begin number 6, we're going to need to identify the variables in our equation. We're going to use this equation, T equals N over CNP plus L plus M, in order to solve the problem. N equals 3, L equals 5, M equals 1, and our P equals 200. We start off with 0.06, which is our throughput, equals 3 over C, times 3 times 200 plus 6. You then simplify into 3 over 600C plus 6. You would then factor out a 3 and divide by 3 until you get 0.06 equals 1 over 200C plus 2. You would then set the equation to 1 and simplify again. 0.06 times 200C plus 2 would get you 0.12 plus 12C. You would then subtract both sides by 0.12 till you get 0.88 equals 12C. Divide both sides by 12 until C equals 0.073.
As we can tell by the previous problems, as the number of parts per board increases and all the other factors remain the same, the takt time C decreases. We can notice this because when the boards were equal to 100, we got 0.146. When it was equal to 150, we got 0.097. and when it was equal to 200, we got 0.073.